if I say play, then do you see my screen again?
Yes.
And now I will change the slide. Does it change?
Yes.
Perfect. So I'm ready.
Okay, we are live. We can start the program.
Hello everyone. Good morning to you all. I am Rashmi Joshi, HBNI PhD student. Today we are celebrating the International Women's Day at HBNI. The theme for this year's International Women's Day, according to the United Nations, is Gender Equality Today for a Sustainable Tomorrow, to recognize the contribution of women and girls around the world who are leading the charge on climate change adaptation, mitigation, and response to build a more sustainable future for all. As emphasized by the UN in their theme, women need to be at the forefront on a global scale across diverse domains like science, engineering, leadership, to drive the scientific and cultural movement to bring about changes in the society. This event here brings women leaders in the scientific fields to demonstrate the role of women power in the society. To begin with, I would like to invite Professor P.R. Vasudev Rao, Vice Chancellor HBNI, to the program. Okay. First of all, I would like to request Srimati Bharati Suvarna, AO3 HBNI, to give welcome address. Thank you.
A very good morning and namaskar to one and all present here. HBNI is extremely glad to celebrate the International Women's Day today, and on behalf of HBNI, I, Srimati Bharati Suvarna, welcome all who had come to grace the occasion, and I wish all the ladies a very happy International Women's Day. To join us in our celebration today, we are fortunate to have among us Professor Archana Sharma, Senior Scientist, CERN Laboratory, Geneva, Switzerland, as our chief guest and speaker for today's event. Our heartiest welcome to you, ma'am. I warmly welcome our chief guest for having spared her valuable time to address and deliver a talk on an important topic, adventure of a particle physicist and why I should care. I'm sure this discussion will be very useful to all the students, faculties, and all age group who deal with particle physics. While I welcome you to be part of the event, I thank you for joining us online from Switzerland. On behalf of Women's Cell, I welcome Professor Vasudeva Rao, Vice Chancellor HBNI, to grace the occasion. On this occasion, I express my gratitude to Vice Chancellor HBNI. Your presence has been motivating and encouraging always for us, sir. I also welcome Dean HBNI, Registrar HBNI, all senior officer of HBNI, Professor Uma Shankari, Chairperson of HBNI Women's Cell, of members of HBNI Women's Cell, all directors of all our CI, OCC, Dean Academics, faculty members, senior scientists, my colleagues from Central Office and HRDD. I also welcome two HBNI students, Mrs. Rashmi from BRC and Mrs. Rucha from Attract, who had consented to talk on their experience as HBNI student. Once again, I welcome all to this event.
Thank you, madam. I would like to invite Professor Priya Vasudev Rao, Vice Chancellor HBNI, and request him to give introductory remarks. Sir, please.
Professor Archana Sharma, participants here in the council hall as well as online from different institutes of HBNI. Very good morning to all of you, and it's a great pleasure to meet you all on the International Women's Day. All those who are associated with nuclear energy or radioactivity know how much one woman, Marie Curie, contributed to the development of an entire field. And she was in fact responsible for coining the word radioactivity itself. It was through her paper that this word was coined. We know how she struggled against all odds and finally emerged as a winner of the Nobel Prize in Physics and then Chemistry. This honor was shared only by three other individuals, Bardeen, Linus Pauling, and Frederick Sanger. The other person we know is Lhcb, who gave us the understanding of the process of fission. But for that, it would have been difficult to think whether the nuclear energy would have progressed the way it has progressed. Otto Hahn, of course, discovered nuclear fission, but what was the process being happening, and that was explained only by Lhcb, even though she never got recognition for that work. But Marie Curie and Lhcb were followed by several women scientists who have introduced the world to the benefits of nuclear science and technology, and that's how we are all here. I read that the first women scientist to be selected by Dr. Homi Bhabha to join TAFR, she was Biba Chaudhary, and she did her PhD with PMS Blackett, who was earlier associated also with Homi Bhabha and who worked on cosmic ray showers. Her field of specialization was high energy physics, and it's an interesting coincidence that today we have with us as the chief guest of the day, Dr. Archana Sharma, who is making very impressive contributions at CERN. That is an organization again devoted to research in high energy physics. It's my great pleasure to welcome you, Dr. Sharma, amongst us, and we are grateful that you have joined us at 6:30 in the morning your time. It's something very, the kind of importance you have given to this event is something we have to be grateful for. I learned that besides her technical prowess related to radiation detectors, Dr. Archana Sharma also has keen interest in human resource development, and that brings her very close to HBNI. She runs an NGO called Life Lab Foundation. I looked at its website and I was immediately impressed with the objective stated in the website, which was inspiring the scientists of tomorrow. This NGO is organizing special programs for inspiring young researchers by giving them access to global experts and cutting-edge science. This is something very close to the objectives of HBNI as well, and therefore I am very keenly looking forward to listening to her along with all of you. I just want to take just a few minutes to discuss the story of two unique women innovators about whom probably you would not have read or heard about. The first is Tu Youyou. She is a Chinese scientist, the winner of Nobel Prize in Medicine for the year 2015. And her story is amazing and has lessons for all the researchers. She was the first mainland Chinese scientist to have received Nobel Prize in scientific category. First person from Chinese mainland. She studied pharmacology, learning how to classify medical plants, how to extract the active ingredients from these plants and determine their chemical structures. That was her work. But at that time, there was the famous Vietnam War going on. North Vietnam asked China for help with battling malaria. And this malaria was being resistant to the chloroquine medicine. And they were losing a lot of people. So North Vietnam requested China whether they could help to find out another drug that could be used to treat malaria. And because the war was going on, the chairman of the Republic of China, Mao Zedong, he launched a secret drug discovery project on 23rd May 1967. Because it was 23rd May, that is fifth month, the project was called Project 523. It was a classified secret project. And this was for just finding a medicine for chloroquine-resistant malaria. And Mao Zedong, the chairman, called this lady, Tu Youyou, and asked her, can you find out a drug which can be used to cure malaria in our soldiers? And she turned to Chinese medical texts from various dynastics, earlier medicines, and to find a traditional cure for malaria. Finally, she extracted a compound called the artemisinin, and which has now saved millions of lives and of course earned her Nobel Prize also. I told the story at ACTREC. I don't know whether you were present at that time. The reason for choosing this story was unique. What was special about her? Not that she did this research. That was not the only point. Was it merely that she discovered something unique? Yes, of course. But what was special was she did this without a doctorate, without a medical degree, and without any training abroad. Everything indigenous based on her own traditional knowledge. She could do something that could become a Nobel Prize winning discovery. In fact, in her country, she was very often jokingly made fun of. She was called three without training, without degree, and without any collaboration. So I mentioned this when I spoke to ACTRAC students in December, because people very often think that the doctorate degree is a destination. It's not a destination. It is only a formal training is important. A doctorate degree is important. But what is more important is a flair for innovation, hard work and commitment. And this way, PhD is not an end result. It's an enabler for us to work for the society. That is what is required to be understood by every researcher. The second person is again a unique person about whom I myself read only some 10-15 days back. It so happens that her birthday falls today. She was born on 8th March. Her name is called Josephine Cochran. And what is special about her? She is the person whom we have to thank for the modern day dishwasher we use in our house. And I read about her. If you read about her, it's so inspiring. Of course, she is from late 19th century, not more than 150 years back. Her dishwashing problem started when she married a wealthy merchant whose name was William Cochran. She had to hold many frequent dinner parties, all these counts and all these famous wealthy men. They will have parties during the weekends for others. And she had to wash the plates. And these meals were served on very expensive ceramic plates, and the household staff were breaking it during washing. And she herself tried it, and she broke many plates. Then she decided that there should be a mechanical washing machine for the plates without breaking them. This was just not known at that time, and there was nobody willing to come along. If you read the US Patent and Trademark Office website about her, it seems she said, if nobody else is going to invent a mechanical dishwashing machine, I am going to do it myself. And then she had no technical background, but then she contacted one of the friends who was having a mechanical background. She designed her first model in the shed behind her house with the help of a mechanic. And her machine which she made was the first machine to use water pressure instead of scrubbers to clean dishes. She was granted a US patent, and she built the machine for friends. Then finally, she displayed her machine at 1893 Chicago's World Fair, where she won an award for the machine's design, and it became world famous. And she then opened the manufacturing facility. All of this without any training, just because she was passionate. She decided this is a very important instrument required for all women to help them. And she set up a facility near Chicago. Finally, ultimately, she was inducted into the US National Inventors Hall of Fame in 2006. But the interesting point comes here. What happened to that company later? What is most interesting to note is that in 1926, her company was acquired by KitchenAid, and then it has become part of Whirlpool company. That is the dishwasher many of us use in our houses. We know where it has come from. So if you look around, you can see women in all walks of life and profession, including science, entrepreneurship, teaching, arts, sports, banking, and so on, making a mark everywhere with their very innovative spirit. So it's just that all of them are not recognized the way men are so easily recognized, and that is why the theme of this one is equality, which is very important. I congratulate the Women's Cell for organizing this webinar, and as I said before, I will also like to encourage the Women's Cell to go beyond the annual celebration. We have discussed some few ideas in the past 1 hour, how to provide further help to the women staff who are working here, in what ways, and to empower them. And we will be most happy to listen to your suggestions and address them. So I thank you very much for giving this opportunity to me to read about some women scientists also as part of this occasion. And we wish you all very well as part of the Women's Day celebrations. Thank you.
Thank you, sir. Now I would like to request Dr. Uma Shankari Kannan, Chairperson HPNI Women's Cell, to introduce today's speaker.
Thank you, Rashmi. And Professor Rao has set the tone of this today's meeting very nicely by giving some two inspiring stories. Now we have another inspiring person in front of us who's going to speak today. I have the pleasure to introduce Dr. Archana Sharma, who is a senior physicist at the CERN laboratory in Geneva, Switzerland. She's active in the field since 1989. She's a pioneer of the gaseous radiation detectors. Following a graduate degree in nuclear physics from the Banaras Hindu University, Varanasi, India, Archana received her particle physics PhD from the Delhi University in 1989, followed by an instrumentation for high energy physics doctorate from the University of Geneva in 1996. Sharma had earned an executive MBA degree from the International University in Geneva in 2001, and having completed the High Impact Leadership and Sustained Development and Climate Change course from the University of Cambridge, she is an internationally recognized expert for her work on micropattern detectors for high energy physics research. Since 2001, Archana has spearheaded the construction of gaseous detectors and upgrades on the CMS experiments at CERN. Her projects have spanned 17 countries and have yielded over 70 PhDs. Archana is on numerous committees and plays a vital role in advisory review boards for leading international conferences, publications, and symposia in the field. She is a reviewer of the European projects since several years and has also been a key member of the Science, Technology, Innovation Policy Committee for the Department of Science and Technology of India since 2020. Sharma is the main contributor of over 250 publications and a co-author of over 1,000 publications in peer-reviewed journals, from experimental collaboration mainly in the CMS experiment, and has delivered over 50 keynote talks in international conferences and public addresses in various science and technology events. She serves as a senior advisor for relations with international organizations with a mandate to support CERN. CERN's objective of integrating the perspective of fundamental research by serving as focal point for CERN, notably for the United Nations system and other organizations based in Geneva. She also actively facilitates the technology transfer to India. There's only a small, brief CV of her. Her list and her is quite long, which I cannot do justice for her in just a few minutes. Also, since all of you would have seen her abstract in the thing, but still I would feel for the completion to give a small introduction to her talk today. She is going to talk on an interesting topic of adventures of a particle physicist and why should I care? The title itself is very interesting. She says, imagine a life without the words of www or HTTP. They emerged one fine day from a scientific laboratory. The Large Hadron Collider LHC at CERN, Geneva, Switzerland is home to thousands of high-energy physicists. By exploiting large sophisticated radiation detectors designed and constructed over decades, we are cumulatively seeking answers to questions about the origin, evolution, and composition of our universe. At this forefront of scientific pursuit, working hand in hand with industries, spin-off technologies have completely changed our lives. With the World Wide Web, medical imaging, diagnostic and treatment techniques, high-performance computing, space exploration, art restoration, to name a few, the audacious, innovative, cutting-edge technologies of particle physics have entered and transformed the mainstream society. In this talk, she will trace the exciting adventure at CERN and how we can collectively fight pandemics and catastrophes that are unknowns like COVID-19 and some known and silent challenges like cancer. So over to you, Dr. Archana.
Thank you very much. Namaskar. And I cannot tell you how humbled I am and very privileged to have been invited by you, Dr. Uma Shankari. Thank you very much, Professor V.R. Vasudev Raoji as well for your kind words and encouragement. Of course, India is very close to my heart. And what you may have noticed also is that there is a long learning before anything can happen. So in the list of you have encountered Dr. Uma Shankari, you will see that there is a a PhD from the University of Delhi, another doctorate from the University of Geneva. Now, why is all that? It's just a path of learning, and learning has been continuing to date, so to speak. I will try to maybe show you a little bit about my feelings about the International Women's Day, in women in science, women in technology, in engineering, how people have made their mark despite a lot of challenges. I mean, women have to speak up all the time. As you know, it's never easy. And it was already mentioned by Professor Vice Chancellor Ji about Biba Chaudhary. And as you rightly said, I do relate, because it's incredible that when I looked up her work, recently I was writing an article on her, because there was a special book that was released last year on the life of Biba Chaudhary, and to not lose our heritage and the work that she has done. And the interesting thing was indeed that there was a lot of instrumentation that she worked upon, and we still use much of the work that she has done in the field of cloud chambers, building bubble chambers, and what she did in terms of making these objects in the laboratory. So on the top left, what you see is a multi-plate cloud chamber in the museum in the Tata Institute of Fundamental Research. And you see here she was with Professor Powell in Michigan, where she worked as well. She worked in Manchester. And of course, these are some of the works that she published in the journal Nature. She is an Indian woman who has published 3 articles, not one, single author articles in the journal Nature. So imagine in the 40s and the 50s, if she could do it, we definitely have to woman up, and we really need to take from her. So creativity and novel ideas are really what we bring along. Exposure is definitely important. However, today we have no excuse. I'm really addressing and sort of the younger I can't call them children, but the younger students, the PhD students here, that if you have a plan, if you have a dream today, you can certainly do exactly what. And this is the lesson in my life. It took me 10 years or 15 years even to understand how to dream in that direction. So dreaming is very important. Role models are very important, and a plan is very important. And I can tell you that today I can say, if I want to perhaps, make a dream come true, I certainly will be able to do it. Of course, with the help of a lot of creativity and a lot of looking around in the world of technology and instrumentation, which is my forte. So clearly, you all in physics, I have seen a lot of work in terms of the various nucleus that you are working on, and I have seen also many PhDs from HBNI. I have been privy to as a reviewer sometimes, and I see the enormous quality of work that is being done over there. So I think that the ingredients are already there. We can really take this to another level, making our ambitions higher. And of course, as you all, I have also been looking a little bit in the same field. The ultimate is indeed to find a unified set of laws which address the micro, which atomic level, as well as to the macroscopic scale of life, like the extragalactic scale and so on. And it's incredible that given so much work by scientists and physicists in the past, this ambitious goal has been realized to a certain extent. You know all the laws that are written here, and all the particles on the left, which are well known to you from the Standard Model. And of course, we know the structure of the atom to the core in a very good way now. Although a completely unified theory of physical phenomena has not yet been achieved, a minimal set of fundamental laws appears to account for the known phenomena. And And obviously, there have to be still questions. That's why we continue. So we need to continue questioning, and we need to continue why and how. So let's some of the open questions. Open questions are, what is the origin of, and perhaps you all, of course, know the answer to. The nature of dark matter, do not understand what is 95% of the rest of the universe, and the rest of all the knowledge that we can gather together, we are unable to explain 95%, and which we call dark matter and dark energy. And another question is, why at all are we here? So it means that there is a certain asymmetry between matter and antimatter. So that those are also open questions beyond standard model. And SUSY, that's the supersymmetric particles, do they exist? Questions on hierarchies. The monopoles, do they exist? Questions on neutron lifetime, proton decays. So these are some of the questions that are open, but then they give us the opportunity to be inventive, to be creative, to understand and propose theories, perhaps, and also to do experiments in nuclear and particle physics, also in high energy physics. On the top right, what you see is the experiment, which is also on my picture. That's the CMS experiment. And I've been extremely fortunate to have had the opportunity of working in at CERN, first of all, and also in this experiment. So sharing a little bit of that with you is what I would like. And I would, of course, passionately hope that you can take away some lesson from the journey that I have here. So CERN is a very large European laboratory. So only member states, they fund this laboratory, and people from all over the world, including India, work here and work in the experiments that are done in the theory as well. There are engagements where we have our scientists, who are amazing scientists, by the way, given amazing solutions, and we try to come together to work together in the different experiments and in the different programs of research at CERN. You see here, this is Sam Ting, one of the Nobel laureates, who has been at CERN from times when I came as a student to CERN. It was exactly like same, and as you see that he is working. He was the spearheading the AMS experiment on the ISS. So he's been very, very productive, and like an icon, he's been there, of course. So all of us collectively are looking the answers to the fundamental questions that we posed, and we are detectors from Biba Chaudhary's small tabletop experiment. We have moved to very large systems, and we are pushing the limits of technology. So we push these limits so that we are able to do the scientific research and try to answer that we said. Now we can actually look at these opportunities for scientific research and for bringing cutting edge technology and R&D together. What does it mean? It really means that to answer the questions that we pose, we need to build apparatus and equipments that are so huge. You all have heard of the Large Hadron Collider, which is 27 kilometer circumference. And left, you see the tunnel, you see part of the superconducting magnets. Now imagine it's an oxymoron. We have the largest equipment on the planet for doing particle physics. Look at the smallest subatomic particles. So how do you even align these to the point where you can measure 7 to 10 microns out of an apparatus which is 27 kilometers in circumference? Similarly, detectors, they need to take data 40 million times a second. And if we were to keep all that data with us, we would be completely swamped and submerged. We need technologies which can accept data on triggering, on good and relevant information. So those kind of cutting edge radiation detectors is what we have been working on for the Large Hadron Collider. And clearly, these detectors can then be used for imaging. It was already mentioned, for medicine as well, for isotopes, for cancer therapies using proton and ion therapies as well. Clearly, the social impact is obvious, I think, but we need to create that as a content. The social impact is unbelievable. Reason being that the sustained development goals, take the example of cancer, take the example of the environment, climate change, who will be problems? These problems will be resolved by the young students who are sitting in high schools today. So we need to connect the scientific research that we are doing to the students who are sitting in the classrooms today, and of course try to solve the problems like the unknown blue COVID. So yes, this fundamental research that we do at CERN is a driver of innovation, and the investments that are done in basic research through these kind of mega projects are essential to unlock that potential with a wide social impact. So yes, it is extremely, extremely important to imagine the social impact that comes out from the mega science projects, and of course the project from the tiny tabletop experiments still are being done, not only at CERN, but all over the world. Now, imagine that all this work, 17,000 people who work at CERN, all that has to be coordinated. All that has to be understood in terms of the physics, the technology, the engineering, the management, the capacity development, the training, etc. And for all that, we have an icon, Fabiola Gianotti, who also was in Mumbai, I think she even came 2 times, and she has addressed a gathering there as well in BRC and Tata Institute. She has made history by being not only the Director General of CERN for 1 term, but she was renewed for a second period. So this is, how can I say, a example that there are no limits of what a woman can do. She is a particle physicist, by the way. She is a research physicist. She was leading the Atlas experiment. So there are no limits, and the vision is really what we need to take as a lesson from lives of people like Lola. So back to our questions and answers. Let's go back to our adventure. That now we have established that any question that we will ask has a possibility to impact millions, if not billions of lives. And in India, of course, it's very close to my heart to imagine how technologies from particle physics can be taken to the society. And even if it is a small type, how do we go from this prototype into the... So those of you who are imagining how we can do that, I think you have to start dreaming. You have to make your hands dirty. You have to go to the laboratory. You have to take all opportunities possible. And there is no excuse, in fact. Yeah, this I think everybody knows, of course, by now. And also you all have studied, you are studying, and perhaps you're even going into greater detail. How do we know this? We know this because we are doing a lot of experiments. And in these experiments, we are smashing things together to comes out from there. So let's imagine 2 helicopters made out of Lego. And these helicopters, let's smash them with some small energy, and you see picking up now. So what is it telling you? Of course, that these helicopters out of Lego are composite objects, and the resulting fragments are pretty big. Now, how about that we increase this collision energy? I hope it is playing on your screen. So there we go. We have got the fundamental. You couldn't have told that this is a helicopter if you just have the pieces. So now we increase and we get even smaller smaller particles, smashing things together using some apparatus to break particles or to break fundamental objects, and then find even finer particles is the game and the we are playing at. And now you can see left there is a scale in orange, you that I have increased the energy and I've managed to smash the helicopters into its constituents, and those are the building blocks of my helicopters. And of course, been doing this over and over again using cosmic rays, using even there has been huge amount of work as well on cosmic rays and in the Kolar gold fields, where Biba Chaudhary also worked, by the way. I have seen a picture of her in a helmet and she has been working in the KGF experiments. So yes, it's very inspiring to see how women have contributed as well to the picture of what we know today of matter. So let's go further. How about we increase the energy further, right? And do that, what's coming out here? It's unbelievable. We all believe in dinosaurs, but how do we believe that? Because we have seen fossils, we have seen signatures, and it started from our helicopters. So what does it tell us? It tells us that E is equal to mc squared can be used in our accelerators. And here is big bang that was created by making the Large Hadron Collider, where two protons are colliding and they generate in a very tiny space temperatures are a billion times than that prevailing at the center of the sun. So using this one equation, E is equal to mc squared, we are able to recreate the Big Bang, of course, in very controlled conditions. And it gives us, illustrating the experiment, if you see here, highly expected particles, because we know the standard model and we know which are the kind of particles we will expect, and we find them and we calibrate our equipment, calibrate the whole experiment using these highly expected. Some of them are hypothetical particles, some of them are extinct particles, the Big Bang, and some of them are unsuspected particles. So yes, using these experiments, and we are able to foresee some hypothetical particle. And this was, of course, before 2012, because all of you know that what is written right over here has been already found at CERN. So back to the questions. We go back to our question, see that which questions we can answer and what are the opportunities. Obviously, for kids, if they are listening, it is by studying science, technology, and engineering, mathematics, of course, nuclear and particle physics or high energy. And of course, women are really at the forefront, particularly from India. So you all have heard of me. She has done amazing work and a very impactful work. She is a Padma Shri, of course, and recently she got an of National du Mérite by the French government as well, out all her awards the whole day. But very proud of our people who have been working in India, from India, in answering these questions. So they are curious people. They are answering the questions. Nishita Desai has been working. Suchita Kulkarni has been working in the theory. All these are theory people, by the way, and they have been working on explaining which kind of, for example, let's take Nishita, been working on the she's the convener of the LHC long-lived particles working group under the LPCC, and Suchita has been working a lot in terms of new searches. So who knows, she will be coming up with dark matter, dark energy, how can I say, clue to understanding what we need to do. All right, so how are we doing in, so on the theory, we have seen that there are people who are working, working the theories, but then these theories need to be proven in the experiment. For that, we need accelerators. which we said to smash things together. Then these will be the powerful machines that I hinted to already before. Now, when smashing happens, like protons, they are smashed, there will be collision debris, and you need to look at this debris, and for that you need detectors. It's like cameras that are recording the particles out of the collisions. We need to collect, store, and distribute the enormous amount of data that is produced. And of course, we need a very large collaboration so that technicians, engineers, scientists, physicists can all come together and work in these experiments, right? So Large Hadron Collider is the largest machine on the planet, I already mentioned. And of course, this is housed in France and Switzerland, where I am. So if you look here, just to place ourselves, this is the airport of Geneva, and you see here a dashed, not a dashed, but a line made out of little pluses. On the right side is France, and on the left side is Switzerland. So you already have two countries here. And our accelerator has protons that are going back and forth between two countries without a visa or a passport, and they are making collisions 40 million times a second in 4 different places. Now here you can see this is Geneva, the Alps, the nice Alps that you see in our Bollywood movies, and Switzerland and France. You have these 4 experiments: Lhcb, CMS, Atlas, and Alice, underground, 100 kilometers underground. Depending on where you are on the accelerator, it's not exactly 100 everywhere, but we can get into that question later. So these protons, then they go around, and these are the engineering marvels that you see, which are the experiments which we have put together. It took, I think, from 1992, 93, the discussion started, and these started in, when did it start? In 2008 it started, and then the first collision data started in 2010. So you can imagine it's a very long adventure. You need to work together with people, and it's a career. It's a lifetime, in fact, that is invested in these of thousands of people, of course. Here again, just to place you where we are, and of course you can also see where I am sitting. So let's imagine Atlas is here. It means this is CERN, that's the airport, and I'm right here, very close to CERN where I live. Okay, lots and lots of results have come out, and I will not go into of these results, which you all are probably very, if you are studying in this field, and if you are not familiar, you can easily pick out these beautiful results, which are the accelerator at the places of the experiments. And here I show you some experiments. Alice is an experiment for studying the quark gluon plasma. Atlas and CMS, they are multi-purpose experiments, and LHCb is looking at beauty physics or matter-antimatter asymmetries. So let me bring back the theme of today, which is, of course, the women scientists. And I will, of course, focus on India, because these are people who are really contributing at the forefront. Here you see Professor Anju Bhasin. She was the vice chancellor and physicist from Jammu Cluster University, and she contributed in a big way at the Alice experiment. And here she is taking visitors around, and she also has, we had the visit of our president Pratibha Patilji also at CERN. And this is Rashmi Raniwala, professor from the University of Rajasthan as well, who are contributing in a big way to the Alice experiment. Not only senior professors, but also young girls. And I'm very proud to say that I see more and more girls coming into high energy physics, which is such a challenging career, to be honest. I know how I have my life, with my family and, let's say, sacrifices, apart from the challenges that you have at work. Even I will not go in the detail of challenges for a woman, because everybody knows about that you have to push extra hard to be able to even perform and be judged as equal to a man. So yes, this is Natasha. She was the first person to study nuclei and anti-nuclei production at the LHC, and she published the first paper in Alice on this work. And you see many other women over here, and some people you may already recognize here. There is Tapan, there is Sudhir. What else can I point out? This is Anik, Professor Raghav from IIT Bombay, Professor Agarwal from Chandigarh, and Professor Bikash Sinha here. Now, still remaining in the Alice experiment, you see Shaista Khan from AMU, Aligarh Muslim University. She has been working on the study of net charge fluctuations in lead, in proton-proton, proton-lead, and so on in the run-to data with the Alice detector. And here they are seen in the middle. You can see her in AMU working on the detector as well. So it is just a showcase to tell you that there are many more people who are working in the Alice experiment, girls I meant really, who are taking leading roles and contributing in a very big way to the Alice experiment. So now let's move to Lhcb, and Lhcb is of course the B physics experiment, and we have the Panvita Dutt, who's been working in frontline physics questions, charm decay modes. She's been working on D to V gamma and V phi rho and K star studies, and she only did those studies, which is data analysis, sitting on your computer. However, she's also working very much in the forefront of assembly and testing of the Lhcb vertex locator, which is a silicon-based detector and one of the most sophisticated silicon detectors planet, if I can say so. So now just to remind you that Atlas and CMS, these are engineering challenges. Of course, they are wonders. So if you look at here, a tiny girl over here and another tiny girl over here, you can see the size of this experiment is like a 6-storied building. It's 100 long and 30-40 meters wide, with detectors being housed set up in Atlas, and in CMS, which is like a cylindrical onion of ion and radiation detectors. In a cylindrical onion of the size that you, and you slice it vertically, and this onion is a sensor. That's what CMS is. And CMS is a detector as well, because it has one of the strongest conducting magnets at 3.8 Tesla and a weight of half tons. Imagine one Boeing is 200 tons or something like that. This is the engineering with different kinds of detectors, like the calorimeters or the tracker, pixel tracker, which is made of silicon. All the Muon system, which is where I work, and I've been working on developing the Muon system and putting resistive plate chambers. You have also worked on that, the Muon system of CMS. So just some more pictures showing you where this experiment, and I can tell you a story of how I learned how to drive a cherry picker. It was called a cherry picker, which means it's not like this is a scissor lift, what you see here, but picker, let me see if I can see it anywhere here. No, it's not there. But okay, it's like a, जैसे वो बल्ब बदलते ना स्ट्रीट में, उसमें वो चढ़ जाते हैं ऊपर, जिसका कि एक आर्म बड़ा सा निकल आता है, and then they can go up to a height of 50 meters, 100 meters. So of course, when I joined CMS, I told myself, I can do this, बड़े खुशी से I went and enrolled myself to the course of doing that course of driving the cherry picker. It's like a tractor only. मैंने सोचा गाड़ी तो चला लेते हैं, तो चलो वो भी कर लेंगे. But theory में pass हो गए फटाफट. But what happened is, when I did the practical, I was asked to place a traffic red cone on the top of CMS. And उसको align करने में ही problem हो रहा था थोड़ा सा. But चलो तरह से align कर लिया. फिर जब हम ऊपर पहुंचे, you can see here on the top somewhere here, I had to place this traffic cone. So ऊपर my basket in there, I was trying to align the, it was, just 50 centimeters short of being able to put this cone over there. And I was trying to align this cherry picker, but I was so scared that I might damage the experiment. And tomorrow there could have been big headlines: Archana Sharma breaks CMS experiment. But I going very gently, millimeter by millimeter, that it took me an hour, but I moved the thing over there. So finally, in the end, I told myself, you just have to, and you will be able to do it, whatever the challenge that is coming to you. Now, here I want to illustrate the power of collaboration. It has been mentioned before also that we can work by ourselves. Yes. However, I would like to humbly submit to you that today world, we need to leverage the power of collaboration. I can sit and learn by myself a lot of things, and I do that, and you do that too. However, I cannot leverage other fields that people have worked 25 years, 30 years on for the learning that I need for what I want to do. Which is why these experiments have been so successful, because people from all over the world coming together, and they are able to be very complex. I'm not a superconducting magnet specialist. I'm not a calorimeter specialist. I work only on the muon detector. But even inside the muon detector, you need micro engineering, you need microelectronics, you need artificial intelligence, and so on. So you get the point, really, how we are able to come together. So I would like now to show you some more women whom I admire. And this one is, of course, another lady from India. She studied in Gorakhpur, I think. Now she is one of the leading physicists of CMS, Professor Meenakshi Narayan. Not going to read her accolades, but you can read and you can see how these young, not so young, we are probably the same age, we are making a difference in CMS and mentoring younger women. That's a very important point. In fact, women need to create that sisterhood, so that just like, men can meet in the evenings and stay late at work, but women have to unfortunately sacrifice that part simply because of the social responsibilities that are on their head. Of course, we are sharing all the abilities. Of course, men are, of course, taking their share of the work too. However, the ways we have, grown, and the way civilization has grown, there is still a major chunk that falls in the lap of a woman. So when you see women like these taking charge, I think you can imagine that all men can work. A woman can also work just like a man. It's not about aggressive. It's not about, let's say, showing something to other people. Not at all. It's just to say that, women can help women, and they are able to work. Couple of other women who are really my role models, Paula Catapano. She is a science communicator, and I would like to see more science communicators from India, because science communication is equally important, because we need to spread the word. We need more children who pick up science, and big science for that matter, because, as I mentioned earlier, sustained development goals have to be resolved, and they have to be only by science, technology, engineering, and so on. She is the CMS Deputy Technical Coordinator. Technical coordination means really that making sure every piece fits in this huge apparatus that we have just said. So one piece is being built in India, for example, and is being being designed and constructed in the United States, and another piece somewhere else, and so on. They should come together. They should fit to the, tens of microns or hundreds of microns, depending where it is on the in time as well, because it takes 10 years to build a detector, and in these 10 years, careers change. Who needs to keep that thread? What kind of challenging responsibility is led by Paula? So speaking about communications, we have girls who are working at CERN and also with CERN, not only there, but also in India and elsewhere, who are working. Priyanka is there, chair, and Rich is there as well, who are contributing their own way to the mission of what we do at CERN. So we did speak a little bit about the data and computing that we need in our experiments. And for that, there are another set of challenges, because today, as we lead, big science is in how we look at data and how data impacts other areas of life as well. But for that, we do need to have the tools, and those tools are developed in big sciences like particle physics. So artificial intelligence, neural networks, these are buzzwords today, machine learning, a lot of them have their genesis inside these experiments. We are collecting about, I think, 200 bytes per experiment to look for discoveries. And here again, we have another leader whom you can look up to. I certainly do. She is Tulika Bose, with a very heavy name, coming from India. And she is working as a professor in the University of Wisconsin. She is the deputy manager of the United States CMS Software and Computing in the CMS Experiment. And she has amazing work. I would like you to think about how event building is done in these large experiments, how the events are filtered, how trigger is being used, and so on. But you will be able to see how she has found her way. Of course, many more people are there. I would be able to, I'll just flash, okay? So there is, of course, Kajari at the Tata Institute of Fundamental Research. There is Suchandra. There is Nishu. There is Monica, who are winning accolades for our country as well in the experiment, and see how they have been part of the experiments. Saptaparna, Shivali, these are all people working from the various diffs at these experiments. Another lady, Pallavi Das, she is working as a postdoctoral research at Princeton, and another girl who's also my Hamnam, Archana. We call her Archie just to make a difference. And she's also the run coordinator, in fact, of the Muon system CMS. Couple of other ladies, Shilpi and Sudha, they are working, and they are, of course, leading large parts of these experiments, what you can see and read here about them also. There's Prachi, she's working on the Atlas New Small Wheel. So this is, again, electronics, integrated technology. So this is an incredible new crop of young girls who are, writing the future for how India can engage in these large experiments. So there's Sandhya, there's Deepti, there's Swagat. So just coming back to our experiment here, a real collision. This is the two Z particles going into forms. So that's why the muon system is very important, which is why I want this. The muon system is very important because it can give you clean signatures of physics. In CMS, for example, we have very thin, and in the iron there are shelves for the detectors, and all these points that you see here, they are recreating what happened at the proton collisions. So here you see that in the summer of 2012, there were little bumps that were seen on the data, and this data eventually led us to Higgs boson. It was very exciting. again in detail, but just to show you that these were the bumps that got the physicists very excited. And that's where Cms Sharma came in from IISER Pune, who has actually been working a long time. In fact, she did, I'm not saying that time, but she started, I think, around that time in 2010, 2012, and she's been really working in our field. So this is a picture of the official announcement, the discovery of a particle. There was a seminar at CERN where I went at 5 o'clock in the morning, but I didn't get any place to sit. So I had to sit outside and watch the seminar. And of course, it was a presentation to Australia. There was a large physics conference where this was done. On Tuesday, on October 28, 2013, the Nobel Prize was given to Francois Englert and to Peter Higgs for the discovery of the Higgs boson. But without the experiment, this was not possible. And here again, you see, large contribution from the Indian contingent as well. And I hope that you notice that there are many women right in front who have been participating and contributing to this, the Higgs boson physics Nobel Prize team. Yes, big science also wins many Nobel Prizes, and you see many people here. This one is George Sharpak, who got the Nobel Prize in 1993, who invented the multi-wire proportional chamber. I mean, very simple. Just like gravity looks very simple today. Simple meaning that, I could have discovered it, or I could have made a multi-wire proportional chamber. But then to think of it and then to use the principles of physics, electricity, magnetism in the right way is what they did. Another woman whom I really admire is Charlotte Varakaule. She is of international relations at CERN, and unbelievably coming from a very different culture. That's also something that we need to take into account and factor in terms of our behavior when we are in a large scientific environment. So I took the lessons because coming from India, I would always sit in the corner of the room and I would not be speaking in meetings. I would not be asking questions. I would not be questioning, in fact. And this is where I see that these are qualities that we have to inculcate. We have to come out from the discomfort and be able to ask and to be to imagine that we can contribute equally, if not more, in any setting. So here are some of the students that we have been working with together. Also, LifeLab Foundation was mentioned, and with the help of my director of international relations, we have been able to make an impact in India and in South Asia as such. So this is a collection of about 100 teachers with whom we, in Delhi, where we did a training for teachers coming from CERN with, and in India also picking up the best teachers in the field, and we did a training for particle physics to be introduced in the schools. I mean, son did his master's in physics, and when he was at school, he took physics, and it was incredible to see that Higgs boson was already in the classroom being explained. The accelerator already in the classroom. In India also, there is a dramatic shift in the way things are taught. But yes, whatever little ideas that I thought we can bring, we are bringing, in fact. Just to mention the new projects on the horizon, we have projects like the Future Circular Collider coming up. Now, this is a 100-kilometer collider. Now, one point is that in India, obviously, we cannot be building such large objects or large infrastructures because we have pressing issues. But then we can engage from the very beginning. That is important. In LHC, we are engaged. We are many institutions, many PhDs, many students. But if we have a plan, in 10 years, this is what we want in our country, for example, then we have the training grounds ready, coordinated, and then engaged in the right time. And obviously, girls to take the lead to engage, because as they say, you educate a woman and you educate a family, or you educate a society, in fact. So yes, we need to align ourselves in what is needed in our country. That is, of course, these are the highly demanded industrial sectors in India. There's healthcare, there's infrastructure, information technology, e-commerce, and so on. And of course, there's been lots of work in this direction too, in terms of competitions and where girls are also participating from India, and they have also been winning prizes. That's Dipanvita. She is a physicist, and she manages a area at CERN. So it's again to that working on secondary beam lines and not this kind of very large, let's say, infrastructure is also possible for all of us to manage just when we pick up the baton that yes, we want to do this. So, question, particles. So we can say yes or no. But if at all high energy physics, particle physics interests you, you can imagine that the skill set that will be created is unique. And it is a multidimensional growth, because when you start from a creative period of design prototyping your detector, because it starts from a physics question, obviously. You are not making a detector just for the fun of it, but you want to make a detector for answering a question open in particle physics, and physics, cosmology, and so on. But then this period itself can take 4 to 5 years, 10 years sometimes, and then you execute it, you build your detector, you start taking data, and you make a physics too. But in all that, you can imagine that what are the kind of spin-off that are coming out. You learn about big data, you artificial intelligence, or create algorithms that will then be used by the outside world in financial management. Just to remind you that 68% of the physicists go into finance after they finish their PhDs here at CERN. And so on. I mean, all the rest I don't think I need to highlight, because you know it very well. You can also see this beautiful wrist of my colleague Phil Butler, who has made this picture using the silicon detector imaging that was made for CMS, but then now there is a company called Mars Bioimaging, I think, and that's making these kind of X-rays, color X-rays, 3D X-rays. So it means without any invasion in the body, you are able to see inside the bone structure and so on. So yeah, it can be very, very confusing, all what the that I have described, particularly for the younger. But I encourage you to be confused, because that's where we begin. That's where we start questions. When I did nuclear physics in BHU studying, everybody used to say, why did you pick this up? It is so unclear, it's an unclear physics that you're trying to study. But then that's only the tip of the iceberg. You know that from that time to now, this is what I had imagined in 2009. And this is the technical design report for the Muon EndCap upgrade in 2012. I wrote it down with of collaborators from all over the world. It was approved in 2015. All the money was, these are the different countries that in my introduction, it sounds very impressive, but I have to tell you, it's a lot of work. And we installed the last detector in 2020, yes. So now that the detectors are installed, we will take data and hope to do some good results as soon as we will be able to start the run 3, which is going to start in a few months at the Large Hadron Collider. So yes, you can, it's very much possible. Here you see, this is an all-woman group. Is there anybody? There is a couple of men behind, but you can see this is large all-woman group, and women are really at the forefront in any field you can imagine. Okay, so let's just come to my conclusions. I hope I have convinced you that curiosity and asking questions about the universe, whether it's particle physics, cosmology, or any field that you're studying, in the end, all that comes together. That can impact billions of lives. And of course, we have many, many projects where there are opportunities for us to upskill ourselves in line with national priorities via international projects. Sustained development goals, of course, are well known, and I think that we all have the mentorship of our elders and seniors, like Dr. Kakodkar, who was at CERN when this symbol of cosmic energy was installed. And you can see here the Director General, then Director General of, and this is being signed here, as you see. So there are opportunities, and of course, around the corner. Let me leave you with a small, humble offering to my students. Thank you for your attention.
Thank you, Archana, for a fascinating journey of yourself and also showcasing so many girls and women contributing to CERN and in general particle physics. I would like to start off the question and answer session. They can we do from there also? No? Yeah. There are two questions which I want to ask. One is technical, another one is basically on science administration or how to do science in India. The first thing is how many times the beams have reached tera electron volt in CERN, or is it continuously going?
Well, it's continuing taking data from 2012 with two technical stops. One was in 2015 and another one was the last 2 years. So apart, we are working with TVs all the time. So we started with 3, then we went to 7, then we are going to be at 13 TeV now.
Okay, that's good. Another thing about doing science in India, I see that you have become very successful by doing collaborating in an international project and then going ahead and doing work at CERN. But do we have that kind of opportunities in India today? And of course, you have given a plan or a roadmap for the next 10 years or how we could engage in physics and other multidisciplinary activities associated with particle physics. But given the current atmosphere, is it, some people, of course, have done very well, like Rohini Godbole and all have that international stature. How do you feel that doing science in India or as even PhDs and going further than PhDs, how the atmosphere in India is conducive for doing very good research or frontline research to be counted at an international level?
Okay, I think, thank you for the question. And the way I see it is, it's part of why I started the Life Lab Foundation. Because there is the way research and international engagement has happened in India is in the 70s and the 80s, it was really person to person. You know, I know somebody, so that's my collaborator, you know. That's the structure. So the structure has slowly grown, but it has organically grown. And we need to make a coordinated effort in what we can do. Let me give you an example. In the United States, there are 700 high schools that participated in the CMS experiment. You know, they built a small board that was used for testing of a silicon detector, just for testing. And those 700 boards were built in each of those schools, and then they were used in the testing. So imagine that for a kid they open their minds that there is this CMS experiment, there are these possibilities, and I can be a part of it. So in India, I think that there are, of course, all these institutions that are participating in the various experiments internationally. However, today there are ways and means to not even having the need to travel, yet be a part of it. So what we need are, let's say, at least a virtual platform, which is called a mega science platform for sustained development. I'm just making up something. So mega science platform for sustained development in India. And anybody can engage, which means, you can have CERN, you can have ITER, you can have LIGO, you can have, all these big experiments. PhD students can become mentors if they want, and there can be a structure which can then take a shape of its own and a life of its own inside the country. There are lots of efforts happening. I'm not going to say, I'm not diminishing anyone's effort, because there is huge amount of outreach happening in India in terms of all these this work going on. But I personally feel that the impact can be at least fivefold if we make it more coordinated.
Thank you, Archana. Of course, at HBNI, we do curiosity-driven research, and I'm sure all these students are really inspired by your talk today. I would like to ask the audience either to give they ask questions, or unmute yourself and reveal your identity, and you can ask, or you can put it in the chat box. Is there anything in the chat box?
Yeah, there is something in chat box, but we can see whether any of them want to ask
Any of
anything.
them you want to ask
Any
anything?
of you want to ask any question? You can pull the chair and come here.
Curious to know what is the present status of the
Come.
Yes. You want to pull the chair? You can sit here.
No, it's fine. I was just curious to know what is the present status of the dark matter which you were mentioning.
Well, it is still open. It is open for a Nobel Prize winning idea, and also for a lot of studies. We are hoping that when we increase the luminosity, HLHC, that the Large Hadron Collider has been upgraded over the last 2 years to increase the intensity and the luminosity. So we will have data in the next 3 years where there is a possibility of perhaps finding dark matter. And there are, of course, other experiments going on also, as you well know.
Thank you.
There is a comment from one of the audience that it was an excellent talk. Yes, I think by Dr. Saprani. Excellent talk and information provided by Dr. Archana. So heartening to so many women there who are doing their best. And the cherry on the cake is that there are so many Indian women. Thanks to you, Archana, for revealing their identities to us.
Thank you. Thank you for the opportunity.
Any more questions? Anybody else wants to ask? Actually, we have lost a connectivity from our main room, so we are sitting in another room.
Oh.
I'm just trying to coordinate with the chat box.
Mm.
Can I ask you a philosophical question?
You can ask. I'm not sure if I have. I can try.
I just want to know that when you work on a topic connected with the birth of the universe and so many fundamental questions, where all this came from, etc., over a long period of time, does it go into the philosophic domain rather from scientific domain?
Well, it's an age-old question, as you see. And in India, particularly, Maharishi Karnad had started the discussion 6th century BC. So we have a history of, philosophy and debate around the existence of the universe and about, the cosmic egg and from where the whole thing began. So for me, as a physicist, I think science begins, or rather the other way, philosophy begins where science ends, So science is about corroboration of data. You have experiments and you look at the data. And being an experimentalist, I can say that I will believe in something when I see it. I believe in dinosaurs because I've seen the fossils at some museum. If some, when the fossils were not discovered, and if somebody would tell me that there were dinosaurs, I might not have believed it, right? So similarly, the metaphysics and philosophy debate should continue, because that's where the inspiration comes for the scientists to ask the questions. So it's a hand in hand, just like, theory, experiment. So even pre-theory, we need to be asking philosophical questions. And the way things move, really, I feel whatever little I have seen, my approach and my, let's say, knowledge is very limited. So I can only do so much, even though I have interest in philosophy and so on, but I'm just about able to, imagine, dream my detector and build it and take data, So there are experts out there with whom I engage whenever I have time, or I can read about philosophy and try to bring that some inspirations in my work as well. I would keep it in that respect.
Dr. Nayak, do you want to ask a question?
Yeah, just hello, ma'am.
Please.
Myself, BK Nayak. Nice to see you. And also, I am doubly happy.
हम लोग तो BHU से जुड़े हुए हैं.
इसीलिए हमको बहुत अच्छा लग रहा है आपको देख के. So my question is, you mentioned that 700 schools in USA, they are participating in CERN program. Do we have in India also similar program?
Okay, there is a program, there is something called IPOG. I think it's called International Physics Outreach Group. And they coordinate all these activities. And right now, and I think Bedang Mohanty, right?
Yeah.
So you speak to Bedang, they have just signed some agreements with IPOG. An action is needed, simply, that's all. There's something called QuarkNet also. And I started QuarkNet in India, and I did I think 15, 18 sessions last year, simply because, in the pandemic, I didn't know how to go about it. And because QuarkNet connects all these schools, so they work together. Why can't India work together with them as well? Kisne mana kiya, So we just need to spearhead it. We just need somebody who takes this charge. क्योंकि इसमें टाइम तो लगेगा ना थोड़ा सा. And if we pick up the QuarkNet program in India, which I already started, QuarkNet, I will put you in touch with the right people.
Okay.
So every have a QuarkNet contact. That's how it will work. Every school should have a QuarkNet contact.
Okay.
Once we know how to go forward, then we can run. We know how to work once we have the little, let's say, track defined.
Okay, thank you. I will be in touch with you on this.
Bilkul. Absolutely, yeah.
Thank you so much.
Sure, yeah.
Can I ask one question, please, Uma?
Yeah. What are the advancements observed in the Large Hadron Collider? This is a question by Rishabh.
So Rishabh, what I had explained now, that the next big project is the 100-kilometer collider, and it will be switched on in 2040. Perhaps I will not be there to pick it up. So you and the younger generation needs to engage in that project. That was my message, really. And the advance means, if you're asking in physics, I think, of course, the Higgs boson has been a very big result from the Large Hadron Collider. And as mentioned earlier, SUSY or dark matter particles or any new discovery physics that can be found is going to be the search for the HLLA. Okay.
We have one more question here, please.
Dr. Archana Sharma, this is really indeed a very excellent talk, which is a motivating talk. So myself is Professor Christopher Sylvain, the English Giant Registrar. So in this case, there's two questions. One is, compared with the scientists of foreign countries that you have interacted, so what is lagging with our Indian scientists? The basic or anything which we are unable to get our Nobel Prize, in your viewpoint? It's one question. The second question was already asked by Nayak sir. In what way you can suggest something our HBNI can do something in this motivational program to bring the younger generation into that? Maybe a suggestion for the government of India through HBNI, we are interested to carry out this process. And the third question is, this one is about your idea, information about this INO. What is your view, whether such kind of INO will be really useful for our country, or will it be some base experiments can be done here, which may lead to some Nobel Prize? Thank you.
Thank you, sir. Thank you, sir, for very relevant and pertinent questions. Let's pick up the first one. So Nobel Prize. Now, I have to tell you my own small, let's say, story. That when I came to CERN, you know, I came from India. So in India, I was one of the toppers. You know how you have a golden CV, you have first class first everywhere, you know, PhD, everything. But when I came to CERN, you know, I had never even seen an oscilloscope. So I was flat on the ground. And I saw people, students from Germany, students from Italy, students from France, you know, like this. It was like I know how to read ABC and they were writing novels, you know, something that was the kind of difference, which is the reason why I undertook a second PhD on instrumentation. It was totally on instrumentation, and that it took me 6-7 years to come to the point where I was able to contribute in a meaningful way to the group, you know. So I think setting up a central lab with instrumentation facilities, जैसे कि CMS, can I speak in Hindi? So if we have, you see, the CMS is a very large experiment, very expensive. However, we can break it into a smaller piece, which can be something of a size which is inside a room, you know, inside a 10-foot by 10-foot room. It just has the relevant technologies like silicon, scintillation counters, or it has RPCs or gem detectors. It has all the FPGAs, it has all the electronics and everything that is needed to have a CMS experiment working. Just an example. And it is very visible. You can have cosmic triggers, you know, for example, you can have scintillation counters on the top and on the bottom. So you can have muons from the cosmic rays and you have an experiment. So every student should learn all the technologies before they come out, because even after 30 years, when I see students coming from India, you know, they are able to follow, but they are not able to lead. So when you are not able to think ki kya karna hai, you know, then that's where our, you know, lacuna is. We need to fill up this gap. And HBNI can certainly play a very big role by creating this facility, which I have been dreaming of for the last, you know, 20 years. But it is possible. It's not very expensive. If we can just find the funding to do it, I can help you build it, you know, because it's something that can be done, you know. And you have the RPCs for the INO. Everyone is working on RPCs. So you have the RPCs. You can make the RPC trigger. I think in ARC, in Dr. Lalit Pant's lab, there is an RPC cosmic stand, you know. And that cosmic stand can be converted into this kind of a facility, which can be the national facility for instrumentation, instrumentation capacity building, something like that. So these are just some ideas on that. So it actually is the work on the Nobel Prize and the capacity building that you asked. Nobel Prize really is of, you know, one Nobel Prize is standing on the shoulders of those who came before him, you know. So it's a recognition. I know it's a well-known recognition, and people somehow feel that, you know, it's the way we are made. There is a competitive spirit and we want to get the Nobel Prize. But if we can do Nobel Prize winning research, you know, that is what we want to have in the country. So when this book that I showed, Nobel Dreams of India, you know, I interacted with more than 100 scientists in India. And they are all doing very, very good cutting edge research, you know. So that cutting edge research is equivalent to the Nobel winning research. Now, what we want to see from India is that this research is cited very highly, not by ourselves only, but outside the country. People should be saying, so proud to hear the other day, I went to speak to some of my colleagues about antimatter, and they needed a trap made, a cool trap or something. And he said that in IISC, there is the best work going on in cryogenics for the trap that they need for antimatter. So what does that tell us? It tells us that we have the ideas. We have scientists who are leading the way, but we are not showcasing them. Number one, we are not proud of ourselves. If we are proud of ourselves, we should bring them to the front. That is important. And we need to be together. That togetherness is very important. That collaboration is very important. We should replace the competition by collaboration, because in the future, anything that we will do has to be based on collaboration. Sorry, I got carried away a little bit. Then INO.
Question? Uma, can I
Yes.
ask one question, please?
Yeah, please.
Last question.
Yes.
Can I just say something about the INO? Because you asked about the INO. I think a lot of investment has been done on the INO. We have a lot of senior scientists now who are experts in the physics, in the instrumentation, in the engineering. So I think that can also serve as an amazing center for education. So if that is converted into a high energy physics education center, instrumentation education center, we already have. So I just wanted to complete that. Yeah.
Thank you.
Thank you. Yeah, Balvinda, you want to ask a question? Please go ahead.
Yeah. So, Dr. Archana, as I said, it was a very informative talk. I'm Dr. Sapra here, Balvinder Sapra here from BRC. I have been listening to this discussion that you just had now. I was only wondering a very hypothetical question, that in case you were not at CERN and you had decided to stay back in India, where would you have seen yourself? And you were also saying that the Indians are doing good research. You have been interacting with several scientists from India. So why do you think there is no visibility for the work being done by the Indians, although it is high class, you say? I'm sure they must be publishing in good journals which have good impact factors, good reputation. Then why is it that those ideas are not yet recognized by the international world?
Okay, there are many ways to address this question. I think that they are being picked up. Ideas are being picked up in international collaborations. Definitely, that's my world. Let's pick up your question in two parts. One is that if I were in India, right? So our dreams and vision come only when we are exposed to something, right? So when I was studying in BH, becoming a lecturer in my college was my dream. When I came to do the PhD, then becoming a professor in Delhi University was my dream. When I had the first, let's say, workshop on instrumentation that I attended in Italy, then particle physics instrumentation became my dream. And then you ways where I would get to. And I can certainly say that it is not easy. It's a very big, in India, it's such a big country. And in this big country, we have, how can I say that there are factors which propel you forward, and there are factors which somehow inhibit that movement, So I think if we are to really take science to another level in India, the best way for me would be bigger interaction with our peers in the international arena, and bigger impact, bigger pride in what we do, I think, because we follow very, very nicely, in big collaborations. Also, I want to see people who are leading in big positions, that's what we need from India, not from the Indians who have come abroad, but from India. And there are opportunities, but you need to engage at the very beginning. See, once the tiger is running, you can only catch the tail and be dragged by the tiger. So big projects, either we miss the bus, we are not from the very beginning, then you can set directions and steer what's coming in the future. Otherwise, thing is set. Also for the FCC, which is going on for the last 5 years already, the discussions, pretty much the pie is being distributed, but we need to be inside these discussions. I think that would be a message.
Thank you, Dr. Archana. I think your talk was, like you say, curiosity-driven research is a continuous process of learning, and curiosity drives you. I hope the students also will follow your inspiration, follow you and be inspired by you. As you said, the drive, mentorship, and infrastructure, these three things are very much important. The drive is there when you're young. And of course, you said that we have to be equipped with labs and mentorship. Just now you said coordination and collaboration would come. And so we would look forward to such better days in India for young researchers to do real frontline work. Now to carry on, thank you very much for sparing your time, and especially it's very early morning for you. To carry on with our program, I would like to invite the two research scholars whom we have called. One is Rashmi Joshi. She's doing a PhD in the chemical sciences and is going to submit her thesis. We would like to hear her experiences about HBNI. Over to you. Just speak.
Thank you, madam. Thank you for giving me the opportunity to share my experience at HBNI. I am Rashmi Joshi, and I come from Uttarakhand to pursue my PhD at BRC. Personally, I did not have much exposure to research. However, 1 year of coursework at training school proved to be immensely helpful for me, as it filled the requisite knowledge gap. To strengthen the classroom concepts, the frequent visits organized by HBNI to the laboratories also helped to make my understanding further deeper. And after joining the lab, we had to be ready for weekly presentations. So the presentation culture not only makes us a good speaker, but it also makes us better at delivering the research findings in a motivating and inspiring way. One thing I will definitely mention here is the sophisticated instrumentation facility provided by HBNI to the PhD scholars undoubtedly helped a lot in strengthening the analytical skills of an experimenter. Many a times, I have found myself stuck in research-related doubt also, but in the environment of scientists and learned people around me, they have guided me very well through my PhD journey. As a woman, I feel it is important to encourage female researchers to dare to dream and break the societal barriers so as to ensure the absence of discrimination or bias against women. The research environment at HBNI as well as BRC has ensured me this by providing a work environment that is safe and supportive. I hope more women researchers would come and take the benefit of HBNI and prosper academically. Thank you very much.
Thank you, Rashmi. It was a very good account of your experiences with HBNI, and we are thrilled to hear that you have benefited from HBNI. At this juncture, I would like to say that about 60% of the research scholars in HBNI are women. I would like to proudly say this. I got the statistics recently, and so I'm very happy to say that so many women are pursuing research in HBNI. Now I request one more researcher, Richa Kulkarni. She is doing in her biological sciences, life sciences. She would like to recount some of her experiences with HBNI. She is also a final year PhD student.
Good afternoon, everyone present here, and we're first of all wishing all the women a very happy Women's Day, and a special greetings to Dr. Archana Sharma ma'am. And I'm really, all the more inspired and motivated today by listening to your talk. Also, special greetings to our Vice Chancellor, Dr. Vasudeva Rao. And thank you, HBNI, for giving me this opportunity to come here and, share my experience or have a few words with all the great people present over here. And I'm just a beginner in front of you all. So that's what I feel. So it was always a dream for me to take up science and pursue research. And in my case, fortunately, it didn't just remain a dream, but it's now a reality that I've whatever I had imagined myself doing experiments in the lab and just trying to find out some clues to the lots of questions that come up in the mind. And as Archana ma'am rightly said, that it's all about being curious and asking questions throughout. So, it's now a reality that I've got this opportunity to work in a research lab, and I work in the field of cancer biology being my area of interest since my class 10th, I suppose. So HBNI turns out to be a very special place in that case, because it marks the first step of helping me turn my dream into a reality. So HBNI is special in that case. So as I mentioned, I work in the field of cancer research at ACTRIC. It's a research institute affiliated to the Tata Cancer Hospital, which is in Parel. I think everyone is aware about that hospital. It's very famous. I still remember the time when I got selected for this PhD program, and I was all the more excited that now finally I'll be doing, experiments in lab. I'll be working in a research lab, which I had already all the time imagined of. So when my first day, when I entered the institute, I was, fascinated to see all those big labs, well equipped with facilities, and that any researcher would dream of working in such a lab always. So the environment was all the more enthusiastic, and all the researchers were determined to have some breakthrough finding through their little experiments, through their big experiments that they were trying to do. So being an HBN, I have experienced full freedom to explore what I want. So I think this is very important for any researcher, to have that freedom to go in the direction that you have always, you wanted to explore. So there should be no restriction as such. You should be free to explore different things. So this is possible only when you have all the facilities and the instruments that are made available to you, along with some really good funding. So HBNI has also taught and encouraged us not to just stick to our field of research, but you to gain all-round knowledge of all the different fields in science, and you be updated with all the different branches of science that are people are doing or working in all sorts of fields around you. So stay updated with that. So for that, they arrange a lot of guest lectures for us, which we are made to attend, and it's like over the period you realize how important that is to not just study about your field, but to stay updated about every other field that is the people are doing amazing work. So that's one thing that I would like to mention. I would also like to mention another very important point is about workshops that are arranged from time to time regarding handling different instruments in the field that are being used. So because tomorrow it's like if we may leave this place, we may go out into some other institute, we might carry out our research over there. So HBNI tries to make us independent in by organizing these workshops to handle the instruments. They teach us to do, right from handling the instrument to data analysis to everything independently. So it's like you do the experiment, all the parts on your own. So it's making you independent in that way. And we are also given this opportunity from time to time to present our research in front of all these students, our colleagues, and all the PIs in our institute, which gives us a different level of confidence of defending our data, and all the more speaking about your work in front of others, and all you encounter those questions that PIs ask you, and you confidently answer those. That's at all the way a different sense of confidence, and it gives you different ideas about your own project that you might have never thought of before. So that is another very good and an important point that I would like to mention. The next point that I would like to mention is we in ACTREC are given this opportunity of organizing a national level conference on our own. So it's a conference called National Research Scholars Meet, and it's always organized entirely by the students and for the students. The best part about this conference is it does not just discuss about science, but it discusses about every other field, be it environment, be it global warming, be it climate change. There's a theme every year for this conference. The best part about giving this opportunity to the students is that we understand a lot of things apart from doing experiments and doing science. That is, I would say, the major thing to be highlighted here is teamwork. So we form different committees, we decide on the theme of the conference, who will be the speakers, how to approach them, how to invite them, sending reminders from time to time. All these things teaches us something different from planning experiments. There are other things to be planned as well. So this was a wonderful experience I had this last year. So that's what I would mention. And in the end, I would just conclude by saying that my overall development as a researcher started from HBNI, and I will always be grateful for this institution for giving me this opportunity, for teaching me so many things. And I would take all these lessons, all these learnings with me wherever I go henceforth. And thank you all for this opportunity. Thank you so much.
Thank you, Rusha. I'm glad that HBNI had developed you into multi-dimensional personality with different experiences. You can invite her. Now I hand over the mic to Rucha again. Sorry, Rashmi.
Thank you, Madam. I would like to request now Dr. Anshu Singhal, Associate Professor HBNI, to give vote of thanks. Madam, please.
Good afternoon, everyone, and my wishes to all present on the occasion of International Women's Day 2022. On behalf of HBNI Women's Cell, it is my privilege to propose vote of thanks for this event to all the dignitaries and participants assembled both offline and online. I extend my gratitude to our guest speaker of the day, Professor Archana Sharma, to take out time from her busy schedule to grace this event. Thank you, ma'am, for an interesting talk, providing insights into the fascinating world of particle physics and how it impacts human lives. Thank you also for sharing the glimpses of research activities carried out at CERN and contribution of different women scientists, Indian as well as international, to the research activities. I would also like to express my gratitude to Professor Vasudeva Rao, Vice Chancellor HBNI, and Professor P.D. Nayak, Dean HBNI, for their interest and immense support in organizing this event. My sincere thanks to Professor Uma Shankari, Madam, Chairperson HBNI Women's Cell, for her untiring efforts and guidance in organizing today's event. I would like to express my thanks to all the esteemed dignitaries from different CIs and OCC of HBNI who have joined online for their presence and contribution to make this webinar a great success. I also thank all the members of HBNI Women's Cell and HBNI office staff for their contribution in conducting this event. Thanks are also due to our IT team of Anurag and Rishabh for making arrangements for online streaming of proceedings of this event live. Last but not the least, I wish to thank all the participants present here for making this event a great success. Thank you all and have a great day.
We can thank her and close the meeting.
Thank you, Archana. I think we'll close the meeting now. Thanks a lot for being.
Yeah.
She's already logged out.
She's there. Maybe she's there.
Okay, Archana, we'll log out from here. Thanks a lot for being. I'll talk to you later sometime.
This meeting.